we should be all good to go. Hey, meme. Oh, wait a minute, you can't see me. And now you can. Cool. Let me do this. Let me zoom in a little bit more. There we go. Am I all red? I'm all red today. Hey, meme. Hey, Nathan. Nice to see you here. Cool. So, you know what comes first. I'll share with you this link over here. Okay. Hello. Hey, Mossy Nodes. Cool. So, if you could, or I just shared the link for you to register. Where's the Ask Me Anything banner? There we go. Yeah, that's the one. Cool. We should be all good to go. I'm sorry, reflection makes my glasses a little bit weird. But you can't see my screen. But yeah, if I don't use them, my eyes just hurt. So I'll just use them. Cool. Let's see. Am I ready? Yes. Visual Studio Code is ready. Let me just close this down. That should be good. Awesome. Cool. Well, quick intro. My name is Travel. People call me Bully. I go by him. Okay. I am a robotics and telecommunications engineer. I work at MLH as a streamer. I'm also a pod leader. I'm helping Amanda, which is the one in charge of pod leading, or actually in charge of the fellowship, to manage part of the fellowship that we are having right now. So if you're interested in the MLH fellowship, let me know. Okay, let me know on Discord. Cool. Okay, that's about me. I also work with drones at a startup in Australia. It's really cool. But yeah, that's me. So let's start. Okay, so quick overview. What are we going to use? If you have Google Colab, great. If you don't, you just have to open Google Colab on your browser with your Gmail account. Okay, that's everything. If you don't have a GPU, an NVIDIA GPU in your computer, it's fine. Okay, everything that we do will still work. It'll probably go a little bit laggy, but it'll still work. Okay, I'll give you the two versions, the non-GPU and the GPU. Okay. What else? I think that's it. So let us start. At stage M, of course, as the banner says, ask me anything. Yep, don't hesitate to ask, and let's start. Okay, cool. So we are going to combine two different models. Okay, YOLO and DeepSort. Okay. Hey, Karime. Cool. Okay, so YOLO is purely only for object recognition. DeepSort is the one that's going to be in charge of tracking. Okay, so two different things. One is going to recognize, the other one is going to track whatever this one recognized. Okay, two different things. Okay, cool. Let's take a look at both of them. Okay, so what is YOLO? Let's start with that. What is YOLO? So YOLO stands for You Only Look Once. It's a real-time object detection algorithm that identifies and locates multiple objects in an image or video. Okay, so you can see here in this image, we have cars, bus, person. There's is that a handbag? I think it's a handbag. There's a traffic light just right there. You can see it there. Okay. YOLO by default is trained with a dataset called Coco. Okay, Coco has a lot of things: cars, people, dogs, stuff like ordinary, everyday stuff. Okay. If you want more sophisticated things that we're going to use, then you have to do something called fine-tune. Okay, you can either train the whole model, which is changing the whole weights of the model and training them to fit your needs, or use the pre-trained weights and just fine-tune the last layers. Okay, what does this mean? This is how YOLO looks like. Okay, you can see it's a convolutional neural network. It means it uses convolutional layers to understand images and videos. Okay. Now you have things here called a max pool. You have some layers here, 1 by 1 by 512. Okay. I won't dive into the math of this, but this is how it looks in the backend. Okay, cool. Now, what I mean by training the whole thing is taking the numbers that make the decisions, those are the weights, okay, of each and every single one of the layers, and retraining them to fit your needs. It takes way more time, it costs way more, but it's more accurate to what you need. Okay, now, if you don't need that much accuracy, it's not like you're doing something really professional. It's like your everyday project. Okay, then you don't need to train the whole model. You just need to probably train these last two layers. Okay, you freeze them, you freeze all of the numbers here, and you just train these two, which is called fine tuning. Okay, sound good? All good so far? Cool. So, what is DeepSort? Okay, now we know what YOLO is. What is DeepSort? DeepSort stands for Deep, Simple, Online, and Real-Time Tracking. Is an algorithm used to track objects over time in videos. Okay, even when they move, overlap, or leave the frame. Okay, this means we're going to have cars in the video, and we know that this black car has an ID of 3. Okay, this ID is being given by DeepSort. Okay, so we know it's a car thanks to YOLO, and we know if this car moves, we can keep track of that car thanks to DeepSort. Okay, cool. It's often combined with YOLO. We can see here for object detection plus tracking systems. Okay, basically with deep learning, we can compare two different images or two different objects located in an image and say, hey, this is looks like this thing from the past frame, but it moved, but it's the same. So I'll consider this the same. So it's the same car. Okay, that's what it does. Okay, cool. Now, why would we want to combine both? Okay, well, first time real-time awareness, detect what objects are and where they are pretty much instantly. Okay, that instantly is a little bit tricky. Okay, it depends on lots of things, your hardware, your code, your optimization. Okay, but ideally it's pretty much instantly. There is no such thing as instantly, but pretty fast. Okay, persistent tracking, keep track of each object across frames with consistent IDs, and those IDs you can manage them, you can change them, you can do whatever you want with them. DeepSort gives them to you. Okay, robust applications, ideal for surveillance, sports, analytics, traffic monitoring, and more. Okay, cool. In short, what I said, YOLO sees, DeepSort remembers. Okay, if you don't use DeepSort, then you would say, I don't know, you were tasked to count all of the cars in a video. Let's say that this, what is it? I guess this is a Toyota. So this silver Toyota right here was here at a certain point. Yep. It took it 30 frames to get to this point over here. YOLO by itself will count 30 different cars, even if it's the same, because it doesn't remember. Okay, DeepSort says, hey, wait a minute. It's the same car, it's just moved a little bit. So let's not count it 30 times, let's count it one time. Okay, basically that's what it does. Okay, cool. Let's get to work. Okay, nice. So what I want you to do is open Google Colab. Okay, this is how it looks. Okay, first thing, I'll open a new notebook. Where was it? New notebook. Oh, there we go. Cool. So you can see this. Yeah. If you need me to zoom in a little bit more, just let me know, and I'll zoom in gladly. Okay. Let me just open my cheat sheet with my iPad. That I think my iPad is like okay, 1, 2, 3, it's like 9 years old. Yeah. I don't use it that often. I used it when I was at college. I used to write everything with the Apple Pencil. It was really good. But, I graduated 3 months, 4 months ago. So I'm like, yeah, I don't use it that much either. Only just for reading. The bad thing is, if I want to read my Jupyter notebooks here, not run them, just read them for the streams, it takes a lot of time to load. Cool. Okay. We have some steps to take, okay? We know that we're going to use YOLO. We're going to fine-tune YOLO. Okay. If it works, it works. Yeah. It takes time. Like, it's 9 years old, but it still does the job. Okay, so we know we're going to fine-tune YOLO. We know that we're going to track something. Now, that something, let's actually do RoboFlow. Where is it? Let me see if I can find it real quick. Nope, RoboFlow. Let's see if we can find RoboFlow dash JVUGO. You know what? I'll just do it the easy way. Open notebook. This one over here. Give me a second. I'll just show you what we're going to work with, okay? Football detection, this one. Okay. There you go. And let's do RoboFlow, this thing over here. There we go. Cool. So if you like soccer, then FYI, I applied to be a volunteer here in Mexico City. So I hope I get admitted to be a volunteer to the World Cup. But anyways, because it's World Cup season next year and everything, let's just work with football, okay? Or soccer. Okay, because here in Mexico we call it football, and what you call football, we call it American football. So soccer, okay? Cool. So we know our model. Now, this is what we were going to work with, okay? This first step is really important, okay? And you'll see why when I train the model. Let's take a look at an image, okay? So you can see in this image, it doesn't load that much. Let's see another image. There we go. You can see we have player here, okay? These are called annotations, okay? This is a referee, this is a referee, this is a ball, okay? And this is a goalkeeper, okay? We have a bunch of photos like this. This is called a data set. We're going to use this data set over here, okay? So I'll share it with you so you can use it. This is the data set that we're going to use, okay? Now, the goal of our project is to track the players who are moving in the field, okay? I have a video that I'll share with you. We can do it, okay? Cool. Now, this is our data set. Why is this the most important step and the one that you should focus basically 70% of your energy and time into? You can have the best model, like YOLO. If you have a very bad data set, even YOLO won't be able to understand, okay? So you have to spend a lot of time checking basically almost every single image to see if every annotation is correct. That's why when you're creating or you're solving an application that has to do with AI or deep learning, you have to check your data set first. And that takes a lot of time, okay? Because if something's wrong, then your model will learn wrong. It won't do the job, okay? And it's not the model, it's the data set, okay? I pre-checked it. It's not the best. It does the job, okay? So let's go with this one, okay? Cool. Now, first thing that I'd like to do is import Google Colab, okay? Why Google Colab? We want to save the weights in Drive, okay? By the way, click here and click change runtime type and go with the GPU, okay? A GPU would be is a graphic processing unit, okay? For computer vision, it's really fast, okay? If you are paying Google Colab Pro, you have an A100 and an L4. If you have these two options, because you're paying Google Colab, then go with the Ampere. Okay, Ampere is really fast. The L4 is good, but it's still faster. The A100 it has more GPU VRAM. Okay, cool. So the T4 GPU, and let's connect. Okay, so while it connects, let's write from google.colab import drive, and then we can do drive.mount. This is just to load our Google Drive, okay? Content/drive. Okay. Now it'll ask, hey, do you want this to access your account? Yes, I trust this. Blah blah blah, and it'll run. Okay. It should run. Meme says, could we also run this in a Jupyter notebook, or would it take entirely too long without cloud GPUs? It depends on the GPU that you have. If you have a strong GPU, shouldn't take long. If you don't have one, it can take up to maybe a minute and a half per epoch. We're going to do 50 epochs, so it should be 50 minutes. Up to you. It's up to you and up to your physical computer's power. If not, then you can just use Google Colab, or if you have a good GPU, so use. It's not bad. I think it's good. I think you should be good. Okay. We're using a Tesla with Google Colab, so I think it does the job. An RTX 2070. Cool. Nice. I have a 4060. Runs smooth. The bad thing is the fans in my computer are loud as everything. So yeah. Sometimes I have to. I think I did it yesterday in the other stream. I had to even change the settings of my fans because they were super loud. But yeah, try it. Definitely try it. Okay. Yeah, you saw. Cool. Okay, so now let's install. Now, careful with doing it locally. Do create an environment for Python so you don't install everything that we're going to install in your native Python. Make sure that you're inside of an environment, okay? Not in your native Python. Cool. Pip install -q roboflow. Okay, this is for the dataset purposes only, okay? So while that loads, I said, there we go. We can do from roboflow import roboflow. Okay, roboflow, capital R, please. Let's do rf equals roboflow. Now, okay, before all of this, yeah, use Google Colab, okay? Just because it's easier in this case, and I don't want you to install things in your computer that you're just going to use once. So yeah, you can do it like, you can try, oh no, I'm out of light. Like my light just died, okay. You can use Jupyter Notebook when you have more time, okay? It's fine, a Google Colab should do the trick, okay? Cool, okay, now roboflow, we go back to roboflow very quick, okay? Go to your account, click here in your account, okay? I'm sorry, here, okay, in your little icon, and then it says, where was it? Wait a minute. RoboFlow app, was it here? Yeah, okay, you go to RoboFlow app, then you go to account settings, okay? Then you go to, where was it? Notifications. Oh, wait a minute, is it training? Ooh, that's not good. Give me 5 minutes. Let me just, I have like 50 guinea pigs, but they're outside. So it's raining. I didn't expect to rain it today. So give me 5 minutes. I'll be back, okay? I'm back. Okay, my bad. Sorry. Because mom's not here, and if I leave the guinea pigs out, no, it's not good for them. Okay, sorry, my bad. So meme says we have to create an account for this. Yeah, create an account for RoboFlow. Okay, because you're going to use an API key. Okay, so it's free. It's easy. Okay, you can delete your account easily too. Okay, cool. So let me just, I don't remember, where was it? Helps and docs. Shoot. You have a place. I'm pretty sure it's account settings. Here? Oh, here. Okay. So click on workspace. Okay. And then go to API keys, and you have an API key. Copy this key, and that's the key that we're going to use. Okay. Cool. Meme says, does it matter if we continue with Google GitHub email for the account? Yeah, it's fine. Yeah, it's fine. It's fine. It's up to you. You can use whatever you want. I have a spam email, so that's what I usually use for this account. But yeah, whatever you want. Okay. Cool. So you do RoboFlow parentheses, and then you do API key equals. I have my key here, so I'll copy this one, paste it here. Okay. And voila. Okay, that's the first line. I'll zoom in a little bit more just in case. There we go. So next one is project equals. This is where we're going to import the dataset from. Okay, so we'll do RoboFlow.workspace. Okay, and then we do. You can see here, I shared it before, but the way you get this is, you say it says roboflow.com. After it, it says RoboFlow JVUGQO. Okay, this part right here, in between both forward slashes, are the workspace. Okay, and this is the name of the project. Got it? So we copy this part over here. So we say RoboFlow workspace. That's project, and inside the project we go with this part over here. Okay, all good? Make sense? Yes, I hope it makes sense. Okay, so now, by the way, everything's on my GitHub. Okay, yes, no worries. Let me just share this pretty quick. Stars? I don't have stars. Let me share this real quick. Open source, copy this. Here it is. Okay, it's this one over here. Object tracking template. Okay, cool. Is it this one? Should be. Yes, it is. Okay, cool, nice. So meme says, okay, we will go back a few steps for the API. Yes, no worries. So if you open this link over here, this is for the dataset. Okay. When you open the link, should look like this. Go click on your, click here in RoboFlow app. Okay, the little RoboFlow icon. You'll get transported into here. Okay, click on your user here, account settings. Okay, then go to workspaces. You should have something here. Click on workspaces, and then API keys, and use your private key. Okay, let me know if that worked, meme. Okay. Cool. Okay, so again, let's get back here. Cool. So this is the project name. Okay, cool. So now that we have the workspace and the project that we were going to point at, now we do, hey, I want my dataset would be the project, the version. In this case, it's version 20. I said 20. The download. We want it for YOLO V8. Okay. Why is this important? Because each version of YOLO has its own, let's call it, way of understanding images. So let's download it for YOLO V8 because we're going to use YOLO V11. Still works with the YOLO V8 type, okay? And then it's always good to print this. Dataset.location, okay? Cool. So this should get the workspace, projects, and everything, okay? Meme, did it work? I hope it did. Just let me know, okay, if you need more help. Cool. Okay. So you can see here it says content football players detection. Okay. This means if we go to this part over here, this little icon, use the private one, the private API key. Okay. Cool. Just in case you need it, I'll do this. Oh, my bad. Yeah, there you go. Just in case you need that part of the code. Okay, so you click on this folder icon. It takes a little while to load, but you can see here we have our Google Drive. Okay, you can see my Google Drive here. I have my Collab notebooks, the fellowships, the past cohorts, personal, blah blah blah. Important ones are the streams. Okay, here I have all my streams. Okay, so we were able to connect to Drive. But the one that we're interested now is football players detection 20. Okay, click here and go to data.yaml. And you can see this data.yaml is the one in charge of mapping your images with your annotations and saying, hey, we have 4 different classes. We have ball, goalkeeper, player, and referee. Okay, that's what it does. This is what changes for each version of YOLO, okay? For YOLO V8, this is the one that changes, okay? You can see here, test images, train images, and validation images are listed here. Okay, cool. Now, let's see what we're working with. Okay, we have the dataset, it's already downloaded, everything's good. Let's take a look at what we're working with. Okay, so import matplotlib.pyplot import from pill, which is pillow, import image, capital I, please, import OS, and import random. Okay, cool. So that understand dataset. We take the path of our folder. Which folder? Let's do train by default. You need to download it like this. So in a cell above that, do this first. Okay, so train image index equals none. Okay, we don't care about the index so far. Okay, always, please, when you're creating your functions in Python or in any programming language, add a little bit of a description of what you're working with. Okay, so function to view the data set to ensure it. Okay, like this. Simple, okay? When you get back to your code, you can see, hey, I know what this function is all about, okay? Cool. So, get the real path of the images, okay? So, real path equals a string, could be an F string, okay? We do path, this, and then folder, and then this, and then images. Oh, my bad. Outside of this, / images. Okay. An F string is a string where you can add some variables to it. Okay. We're adding the path variable and the folder variable. And inside of it, we know there's an image. Okay. If you go to test, you can see images. If you go to train, you can see images. If you go to valid, you can see images. Okay. Cool. Meme, you okay? Cool. Okay. Aside from that, let's do get a random image. Okay. So to get a random image, we do if not image index, then image index equals random dot randint, which means random. Okay, cool. Just let me know if you want some more help. Okay, random. Give me an integer between 0 and I don't know how many images are either here, here, or here. But what I know is that I can take the length of a folder. Okay, then I can do the max value would be the length of os.list_dir. Okay, it means I want you to create a list of everything that it's in a directory with the path real path. Okay, now this -1. Why -1? Because if you have the index, if the length is, I don't know, 40, index is from 0 to 39. Okay, so we don't want to get the 40 and get an error there. Okay, cool. Now let's just plot the image. Okay, plot the image. So image equals image with capital I, which is the image that we got from here. Okay, that open. We get an f string here, and it's real path. Okay, slash. Then we get the image. Okay, so os.list_dir real path, and then it should be in index image. Oh, image index, my bad. Okay, cool. So then plt.figure. I want to just get rid of that. Can I? Wait a minute. Well, everyone catches up. Where's the file view? How can I get rid of that? The code snippets, is it here? No, I just want to get rid of the code that shows runtime tools settings, maybe miscellaneous, adaptive, horizontal, editor. Do you know how to get rid of that error? Sorry, that code. Yeah, auto suggest is horrible. Show context for code completions. Maybe it's this one. Is it? plt.figure fig. Yeah, it's that one. Okay, yeah. So we go to, what is it? Tools, settings, and in site, scroll down. No, editor, scroll down and uncheck this one. Okay. I hate auto suggest. It's horrible when I code alone, and when I'm streaming, it's worse. Okay. Okay. So fixed size equals 10 by 10. Okay, this is just the size of the image that we want to plot. Okay, and then plt.show. Okay, image, and then plt.show. Okay, now let's get back to what we did. Okay, if we don't have an index, we can suggest an index, but if we don't have one, get me a random one between 0 and the length of the directory, or the length of, or the amount of images that we have, -1. I don't want to get out of bounds. Basically, open the image and plot the image. Okay, if you run it, nothing happens because you haven't called the function. So let's call it understand dataset. And now in here we do go to your folder. You can use whichever folder you'd like. I'm going to use the validation folder. Okay. Click here, click copy path as a first string, that one. Okay. And then that should be it. Okay, run it. Errors. I love errors. Slash valid. Oh, my bad. Wait, what? Oh, yeah. Okay, I got it wrong. You have to get the main folder, and not the one of these three. Okay. just this one. If you want to change the folder, it's in here. Okay, cool. So 3, 2, 1. It gets a random image, and this is the image. Okay, you can see this dataset mainly focuses on cameras that were on top of the football fields. Okay, if we have a close-up of this person right here, YOLO won't be able to understand who that person is. Okay, but like this, YOLO knows that this is the goalkeeper, the ball is I don't know where, and these are players. Okay, good. So far so good. Okay, cool. So this looks good. Okay, it's a good image, not that bad. You know, the resolution is not there, but still, it's not a dataset that we created, so it's still fine. Okay, it works. Cool. Let's train. Okay, nice. So to train, we have to install something called Ultralytics. Okay, pip install Ultralytics. Okay. Wait a minute. Ultralytics. Yeah, that's what it is. Okay. Let's see. You did some research when you said about dot versus under attributes. You use underscore as a descriptor to make more complicated dot attribute functions, compound functions. Okay. What did I say about it yesterday? Underscore dots. Okay. Yeah, I think I know what you're getting at. What's that? Okay, I'll get to that. Give me a second. So what Shanking is saying is, okay, I get it, but I think what I meant was not as the programming, but as, let's say that in a name. So for example, here you see I always use underscores for the naming. Some if you use C, Java, C++, usually people use camel case, which is like this, camel case. Okay, so I think that's what I meant. I'm not sure if I'm probably forgot about the dot thing. But yeah, if you could explain, if you remember what I actually said or an example, yeah, that'll be helpful. I don't remember what I said about the dots. Meme, what is the purpose of the exclamation point? If you use exclamation point, you are asking Colab to run bash or run it in the terminal, not run Python. If I get rid of this, it says, oh, actually that's interesting. It works, but everything's in errors, okay? If you want to run bash, exclamation point, okay? Yeah, that's fine, no worries. Cool, okay, that should be all installed. Now, and see, in your case, Meme, you have NVIDIA, okay? If someone doesn't have NVIDIA, that's why I always recommend using Colab. It's easier, okay? It has everything for you, okay? And you don't have to install anything, and it's, in a way, free, okay? I say in a way, because if you want more powerful GPUs, you have to pay for it, but still, you have a GPU to use. So, let's train, okay? The thing that will take more time is this. From Ultralytics, import YOLO capitals, okay? Careful there. Now, we need to get the data, okay? Remember, we opened a thing called data.yaml, okay? If you go here, you'll see this data.yaml, okay? This is the one that's going to help YOLO track everything inside of your dataset, okay? Copy the path of this and do data.yaml equals this, but as a string, okay? Cool. Now, model equals YOLO capitals inside YOLO 11s.pt. What does this mean? Okay, we're going to use Ultralytics version 11 of YOLO. S means small. We have nano, we have small, medium, large, and extra large. Okay, each one of those gives you more power the bigger they are, but it takes way more time to train. Okay, I would suggest we use S. Okay, cool. So let's train. Results equals model.train. Okay, now inside of this, remember I said we're not going to train the whole thing, but we're going to only fine tune. It means we are just going to train the last layers. Okay, so we do freeze equals backbone. It means I don't want you to touch the weights from previous layers, just the ones that are needed for fine tuning. Okay, now data equals this over here. Oh, my bad. This over here. Yeah. Okay. Cool. Nice. Next one is epochs. Epochs is basically number of iterations. We'll do 50. Okay. 50 is the one that works for me in a way. Okay. Cool. Image size equals usually YOLO uses 640. Okay. The bigger or the bigger the image, the more time it takes. Okay, cool. So cache equals true. Okay, caching means I want you, Mr. YOLO, to put everything in RAM so it's faster of training. Okay, now this is a double-edged sword. If you don't have that much RAM, it'll crash. In our case, it should work. Okay, cool. Now batch equals 1. We don't need batching. It's not a lot of images. Okay. Device equals 0. Okay. Let's do workers equals 8. I think this is irrelevant in this case. Workers are the amount of threads that you can use in your GPU. In this case, 8 should be good. Okay. The learning rate 0 equals 0.01. This thing is a number that, okay, let's get back one step. Okay, let's say that when YOLO is training, it's a person going down a mountain. Okay, so let's say that the learning rate is the length of the step. Okay, so the larger the what? I don't know why. The larger the step, the faster it'll go down. But let's say that it's looking for something. Okay, so the longer the steps are, the more likely to miss the treasure it is. Make sense? If we do the learning step smaller, the less chances of missing something, but the more time it gets to get to the bottom. Make sense? So it's a trade-off, okay? If learning rate is high, your model will converge faster, but it's unstable, okay? The smaller the learning rate, the more stable and the more it learns, but it just takes too much time, okay? Cool. Yep, share terminology with things I've played with generating images using Stable Diffusion. Yep. When you get it, it's magical. It's like, no way. Cool. Okay, learning language. Let's do it faster. Okay. Optimizer equals Adam W. Okay, that's an optimizer. I won't dive into optimizer right now. Patience equals 20. It means YOLO can wait for 20 epochs if something's not learning. Okay, so if YOLO stops learning for 20 epochs, it'll stop. Okay, cool. Cosine learning rate equals true. I don't remember what cosine RL was. Can we find it here? I don't remember. Okay, honest answer, I don't remember. I'm running out of time, so let's just leave it as it works. Okay, cool. And project, it means where I want you to save everything. Let's do, I went to my drive. Yep, you can see here I have a collab notebooks. I don't want that one. I went to stream. Then I had a collab notebooks, outputs, inside of outputs, okay? Copy path, paste it here. This is up to you, okay? Where you store this is up to you, but store it in your drive, okay? So you don't lose it when the runtime disconnects, okay? No, it doesn't crash. It just doesn't learn, okay? So it can, you can have an epoch that says it's learning really good, and then you can have another epoch that says this is not learning anything. So it's just unstable in the learning, but it doesn't make anything crash, okay? It doesn't crash anything. It's just unstable learning, okay? So you won't converge. Make sense? Cool. Okay, and then we'll add a name equals YOLO 11S football. Okay, should be all good. Run this. You should see something like this. What? What? Training the is not a value YOLO cosine RL. Oh, sorry, my bad. Learning rate. Okay, cool. When you see errors, I always say it in my streams. When you see errors, don't copy paste it to ChatGPT. Learn how to read errors. Okay, so you saw we went here. It says syntax error cosine RL doesn't exist. It's learning rate. Okay, so it's all the way around like LR. Okay, should be all good now. Oh no. Epochs. Oh, see, it's EPOCH, not HT. So my bad. Should be all good now. There we go. Cool. So this is what you'll see. Okay, you'll see this. It's downloading Ultralytics YOLO. Everything should be good. If you click here, you can see how much resource you're using. So you'll see the system RAM go up. No worries. It shouldn't go over 11 gigabytes. It's fine. Okay, I tested it before. It's fine for the free version. Okay, cool. So this is an epoch. Okay, now it's learning. Okay, so far so good. I'll give you 1 minute for questions about this, and then while it's training, we're going to go to Visual Studio Code. Okay, so I suppose I should have asked beforehand, but how large will the output be? What do you mean by the output? So the output by itself has a lot of things. It has some metrics. It has the weights, the best weight and the last weight. Okay, it has metrics such as graphs, confusion matrix, different data that explain how the model did, and you have some examples of how the model did. Okay, I don't know, maybe let's see it in my drive. Stream. What? Hey. I said stream. Pull up notebooks in the outputs. So this is the ones that I tried before. Oh, I don't know. Maybe it's all in the range of kilobytes. 10 megabytes at most. I don't know. 20 maybe. I'm not sure. The weights are, yeah, it's all in the megabytes range. So it should be everything in kilo, mega. Is it giga then? Yeah, okay. So the ones that are heavier are the weights. I would say if those are 18, I would say probably 50 megabytes at most. Okay, it's not that much. Basically half a gigabyte. Okay. Can you please suggest some pets that I can use in PC, like VS Code pet? I'm not sure. I've never used pets in VS Code. If you're wondering about these, you can go to Tools, Settings. you go to miscellaneous, and you have either crabs, kitties, or corgis. Okay, so yeah, you can add all three of them, and you'll see corgis here. Now, if you want VS Code pets, I don't know what, like, share the options, and I'll I'll give you my suggestion there. Okay, he can add a compression. I'll go to decrease the file size that he wants. Yeah, for sure. But it's not that much. It's half a gigabyte at most. Okay. Check your firewall limits, people. I'm safe in that regard, but a month ago this was exceeded it. Yeah, that's fine. It's at least for Google. Well, in my case, I use MLH's Google, so I'm not sure what's the limit. But yeah, always check your limit. Okay. Cool. Nice. Well, if no more questions about this, let's go to VS Code while this trains. Okay. See, it's taking 26 seconds an epoch. We're training it for 50 epochs, so it'll take some time, okay? Cool. Go to VS Code. Let's suppose that didn't happen. Go to stream codes, open a new file in Python. Let's call it detect.py, okay? Cool. Now, we have two options, okay? I will show you how to do it with pip, but not with conda, even though I'm going to use conda. Why is that? Because I don't remember how to do it. Okay, let's do it with both, okay? For people that don't have NVIDIA GPUs, use pip. For people that have NVIDIA GPUs, like me, or me, you can use conda safely, okay? If you have conda installed. If not, then just use pip. I do too, but not for computer vision, because it makes everything really smooth. Okay. Yeah, yes, but not for this. Like, we can try it. You'll see the difference between pip or VNV and conda. It's a huge difference because conda is made for GPUs. I don't like it. It's not very intuitive. It like, everything crashes. The wheels are badly made, but it works. At least it works. But yeah, you can use PyEnv if you want. Okay, a little bit of water. Cool. Okay, now let me go to my cheat sheet real quick. So this is training. This is good. Cheat sheet should be right around here. Stream. Python. DeepSort YOLO. No, this is not the one. I need to go to GitHub. My mistake. Let's see this. Give me a second. I'm sorry. Where are my repos? There we go. There. Code. Open source. Object detection. There we go. Cool. So, from Ultralytics import YOLO. Okay, like this. Now, you'll see that it's highlighted in a weirdy way. It's because my env doesn't have it. Let's do it in pip so we can see how it works in pip. So you go to your terminal. Okay, let's say that this doesn't exist. Conva deactivate. Okay, cool. Now let's go to stream codes, and here I'll do rm-rf env just because I don't want. Oh, this doesn't work with Windows. Wait a minute. Delete. Yeah. Okay, cool. We don't have any env. Okay, suppose we don't have any env. What we do is pi for Windows, pi-m vnv env. Okay, that's for Windows. If you have Ubuntu or you have Mac, use Python 3 -m env and then env. Okay, env is the name that you want to give your virtual environment. Could be, I don't know, stream env, something like that. Okay, I use env always. Okay, to activate it, In Windows is env scripts activate, okay? For Mac or Ubuntu users, you have to do source env, and it's not in scripts, it's in bin, and then activate. Okay, like this. That's for Unix base, which is Mac and Ubuntu. For Windows, do it like this. Okay, cool. Now, pip install Ultralytics. Okay, as easy as that. It'll do its job. In the meantime, we can write some more code, okay? From DeepSort real time dot DeepSort tracker import DeepSort, okay? That's the DeepSort that we're going to use, okay? Now, import CV2, okay? This is OpenCV for images, okay? Cool. Now, I love classes. Let's just do a class. Object detection, okay? Cool. Now, def dunder init. We do self, and then we do video, okay? Like this. Now, let's see how this is going. Okay, you can see this is flickering because my environment is loading. Okay, cool. So we create a class called object detection underscore init, also known as dunder init, is the constructor function. It means whenever you're calling your class, this first function will make sure that everything inside of it is run, even though you don't explicitly call that function. Okay, that's what a constructor is. Okay, so we do load model. Okay, so self.model. Now, what is self? If you're asking yourself, then self is the pointer to the class. Okay, so it's like this in JavaScript. It's a pointer of your class in memory. Okay, cool. So self.model equals YOLO, and then here we'll do model.pt. Okay, let's leave it like this. We'll download the weights later. Okay, cool. So init DeepSort. Okay, self.tracker equals DeepSort. Okay, in here equals 5. Okay, bear with me with these numbers. I'll explain them later as we go. Okay, now let's just write them down and then just trust me. Okay, I'll explain them later. Number init equals 2. Max IOU distance equals 0.75. Max cosine distance equals 0.3. Okay, embedder equals, well, let's use MobileNet. Embedder GPU equals 2. Okay, cool. Now this part is important. If you don't have a GPU, this should be false. Okay, because if not, it's going to try to connect to a GPU, and it's not going to do so because your GPU is the one that is only in charge of your video. If you don't have a specific GPU, then don't use this part. Okay. Okay, cool. Now, this is our DeepSort. Okay, you see Ultralytics is now not underlined. Okay, but DeepSort is. So let's do pip install DeepSort real time. Was it like this? I don't remember. Oh, it is. Oh, there we go. Cool. See, now VS Code recognizes that Ultralytics and DeepSort is in my env. Okay, it should for you too. Okay, cool. So when we call this, let's parse the video. Okay, So parse the video when init. Okay, so self dot underscore. Now I learned this like a couple of months ago. If you name a function with an underscore, starting with an underscore, just one, it means it doesn't change anything in like compiling the code, but for you it means this is just internal code. It means we are if you are going to call this code someplace else, this underscore function shouldn't load for them. Okay, it's, let's say that it's it means it's just a local function for us to use. You can still use it in another part, but it's just like conventional. Okay. Okay. Yeah. But in this case, or what do you mean? Shanking. Double underscore. Yeah, the dunder. Yeah, for sure. But like the dot plus dunder, what does that give you? Because for example, you can call a function like this. Like you can do, I don't know, object dot, I don't know, parse like this. So you can do that. Okay, cool. Nice. So just let me know. Okay. Let me get rid of your comment there. Okay, cool. So parse video. Okay. With video path. Okay. So we have to call this with a path. Okay. Yeah, for sure. Yep, that's a definition. Yes. You are right. Cool. Okay. So compute the video. Okay, it's not the same parsing as computing. Careful there. So you say we should do like this? Maybe. Okay. Let's do it. Why not? Self dot compute and predict. Okay. So I'll leave it just there for like 30 seconds. Explain it for people that are writing the code. We have the tracker here, which is DeepSort. Okay, remember, DeepSort is the one in charge of remembering. YOLO is the one in charge of looking at stuff. Okay. Parsing the video, it means we're going to give the code a path in memory. It should parse the video as a video object and send it to DeepSort and YOLO. Okay, and that should happen here. Okay, cool. Awesome. So first one, let's not predict an image. Let's do def underscore parse video underscore self. Okay, self is okay. Cool. So what does this do? So inside of it, computes and, oh no, wait a minute. Function to parse the video from source into a readable object. Okay, so that's what we're going to do with this parse video function. Okay, FYI, go back to your notebook and kind of go here and click on the refresh like 3 times. Okay, sometimes Google Colab disconnects if you're not active. Okay, yeah, just do it like this. Refresh here so Google Colab kind of feels like you're there. Okay, and go back to Visual Studio Code. Okay, so it doesn't disconnect. Okay, cool. So self.video equals cv2 dot video capture. Okay, and then video path. Actually, this one should receive video path. Okay, cool. So we are creating a video object based on the path. Okay, now check for errors always. There we go. If not self dot video that is opened, then print error with video, okay? Stringify this, and then self video equals none, okay? Like this. Okay, so we read the video, parse it through a video object. If it doesn't work or something happened, we classify it as none and print error with video, okay? That's it. Now, hard part, okay? Cool. Let's go. So, compute and predict, okay? We only need the self, okay? Again, function that predicts and okay, based on the video, my bad, input, there we go. Okay, cool. So let's check if the video is okay. If self not, oh, what's happening? Well, not self the video, then print not or error with the video, okay? And return -1. Usually -1 is assigned to errors, okay? So if you want to return a number with an error, -1 should be good, okay? Cool. So that should happen if there's an error with the video, okay? Let's put it here. If error with video, okay? Now, while true, each and every single frame has to pass through a check test. That check test is made by OpenCV, okay? And we get two things, okay and frame, okay? Equals self.video.read, okay? So each frame should give us an okay. If a frame is corrupt or something is wrong with the frame, then okay is going to be not okay. Okay, cool. So check if error with frame, okay? Why so many checks? Because we don't want DeepSort to crash just because we had an error, okay? Cool. So basically, if not okay, then print end of video or error with frame, okay? Cool. Break. Okay, get out of there because we either reach the end of the video or there's an error in the frame, okay? Cool. So now, predict with YOLO, okay? Cool. So results equals self.model, open parentheses, frame, okay, 0. Okay, that's what those are the results in 0, okay? Cool. So inside of this, we have to extract the detections, which are x1, x2, oh, I'm sorry, it's y1, x2, y2, and then it's confidence and class ID. Okay, so YOLO will give you this. x1, y1, x2, y2 are two coordinates of the square or the rectangle, okay? It gives you a diagonal, okay? So it gives you top, I think it's top left, bottom right, and then you can trace a square with that, okay? Confidence is the confidence of each prediction, okay? Class ID could be, in this case, player, I think it was goalkeeper, ball, and referee, okay? Cool. Now, detections equals empty list, okay? For box in results dot boxes, okay? For each prediction that we made, x1, y1, x2, y2 equals box dot xy. Okay, what does that mean? Box dot xy, it's the format that we got it. Okay, xy, xy. Okay, you can do xxyy, doesn't work with DeepSort. Okay, DeepSort uses xy, xy. Okay, cool. Now, confidence equals a float of box.conf 0. Okay, class equals is a number of the box dot cls in 0. Okay, cool. And now detections that append. Let's do it like this so it's readable. Float. Actually, yeah, let's do it like that. Float x1. I'll copy paste this. Okay. It's actually a tuple. Okay, so open twice here, like this. Right. So x2. I'm sorry. This is y1. And then it's x2, y2. Okay. Oh, my bad. I'll share this part, okay? Just give me a second. x1, y1, x2 minus x1. Yep, okay. I got a notification from Google Chrome. We have the results saved in the content drive. For us, it's football 6. Okay, so it's already finished training, okay? So yay. Okay, cool. Now, and then this should be y2 minus y1. Okay. Now, outside of this list, it's going to be float confidence, and then int just in case cls. Okay. Cool. Now, I'll share with you this part over here because it's a little bit confusing. If you're following along, then that should be helpful. Okay, cool. So outside of the for loop, now we got everything that we wanted: the box, coordinates, confidence, and class. Then update DeepSort tracker. Okay, so tracks equals self the tracker. Okay, that update tracks, and we're going to give it detections. Frame equals frame. Okay, so it knows which frame we're talking about and our detections of that frame. Okay, cool. Now it's done. Now let's see it. Okay, because the computer is doing it for us, but we have to see it. If not, then why do it? Okay. So, draw tracked boxes. So for track in tracks, if not track that is confirmed, then okay, what does this mean? It means if the track that we got is not confirmed, it means we're not sure about it. Let's not mess with that and get out of there using the continue, okay? Which is get to the next iteration, okay? Now, oh, my bad. Cool. Now, x1, y1, x2, y2 equals track dot to LRTB, like this. Okay. Now we got. You can see here it says x1, y1, x2, y2. It says 2, left, right, top, bottom. Okay, that's what we want to get the coordinates of our tracked object. Not this one, but the tracked one. If we get this one, then it's going to be a different one. How can I say this? It's going to be the YOLO one, not DeepSort one. Okay, cool. Now that we got this, track ID equals track ID. Now you can choose not to give it the ID, and it's fine, but you won't be able to access it later. Okay, so it's better if you give it the ID first. Okay, cool. So cv2.rectangle, and inside we do the frame. We want to draw a rectangle where in the frame, or over the frame should be, to the int x1. Let's copy this. Y1. That's a tuple. Okay, so that's one of them. And then should be x2, y2, like this. And then the color of the rectangle will be 0, 255, and 0. It's RGB, so 0 for red, 0 for blue, all for greens. It's going to be a green rectangle. The 2, which is the line width. Okay, cool. So cv2 dot put text. Okay, let's put text over the frame. The text was going to be ID of track ID. Okay, and then basically we have to say where it's going to be. So it's int of x1. This is horrible. I should have added the ints here. Maybe I'll do it now. Int of this, int of this, int of this, int of this. Okay, it's easier to write. Okay, so we don't have to do this. So it should be x1, y1 minus 10. And then let's do cv2 that font Hershey simplex, like this. Okay, then 0.6 pixels of width. Color will be green, which is 0 to 55, and then 0. Okay, and then to here. Okay, cool. So let me just double check that everything's okay. Should be x1, y1 minus 10, so it's a little bit under. Okay, actually should be for OpenCV. It's not, so 0, 0 doesn't start here. Okay, for OpenCV 0, 0 is here. Okay, so y minus 10 should be upper. Okay, for us. Cool. So it's 10 pixels over the line of this rectangle over here. Okay, cool. Nice. So outside of the for loop, show frame. So let's do cv2.aimShow. As a title, we can add YOLO plus DeepSort tracking frame. Okay, if cv2 dot weight p1, this is basically to get rid of the to close OpenCV, because sometimes you might close the window but not OpenCV. Okay, so and 0x double f double equals word of q. Basically, if we press q, then break. Okay, basically quit. Okay, cool. And outside of this, while self.video.release. Okay, this is for, we don't want OpenCV to live in our memory. Okay, and cv2 dot destroy all windows. My bad. Like this. Okay. Again, cv2.im show, we give it a title and then we show the frame. If cv2.waitKey 1 and 0xFF, it means are we pressing this, then break. Okay. Then if we broke outside of this, we make sure that the video is released. It basically says don't keep it in memory and destroy all windows. Okay. Cool. Now, this should be good. If Thunder name double equals Thunder main. For people who are not familiar with Python or don't know about this, this means if we are calling this code from source, not from another part or like another code. Okay, so not like if we were to go like to call this object detection like this. Objects like this, okay, from another part of the code or another code, okay, then if we call it like this, then this part over here won't run. Okay, if we call it directly from name, then it's going to call this part. Okay, cool. So detector equals object detection parentheses to run init. Okay. Then we say detector dot Thunder parse video, and inside of this we're going to, how can I share this with you? Okay, let me do something real quick. Go to drive. I can put it here. New file upload. Streams. Nope, not here. It's in YOLO DeepSort. Images, soccer. Okay. Let's upload this video and I'll share it with you so you can use it too. Okay. Come on. There we go. Now share, copy link, paste it there. Oh, maybe I should give you an authorized link. Wait a minute. Share. Anyone with a link. Copy link, paste it here. Okay. That's the video that we're going to use. Okay. It's on Drive now. You just download it and that's it. Okay. Cool. Okay. Now, here we should paste. I'm going to paste the path of this soccer.mp4. I'm going to put it in stream codes. Yep, move. There it is. Okay, so it's here. So I'll do soccer.mp4. Okay, that's the video that I'm going to parse. And then detector.compute and predict. Okay. That should be it. Okay. Again, this soccer mp4, it's in the drive that I just shared. Okay. Cool. Last thing. We need a YOLO weights. Okay. We got two options. Okay. We're going to use both of them. The one that we trained and the one that YOLO comes with by default. Okay. Here we're going to do YOLO s.pt. It's YOLO 11s.pt. Okay. The one that we trained. Okay. Now, this is untrained. This is just with Coco dataset, which is people, dogs, balls, stuff like that. Okay, basic stuff. Okay, cool. You don't have to have this downloaded. It'll download it for you when you run this. Okay, now you can use pip as you used it. Okay, I see that meme despise this conda. Okay. I'm not going to share how the conda part is done because I think there's a problem with the wheel, but I just don't remember how to solve it. So it'll take time. So I'll just do it with my conda. But you can do it with pip, running it with pi, detect like this. Okay, cool. in my case, I'm going to do like this and then conda activate garbage. Cool. Now, like this, let me run this. Let's see how many errors we've got. Yeah, there we go. Why? Let's see. It was here. Int x1, int x2, int x3 equals track. Should I get rid of the int, maybe? Int here. Maybe Python doesn't allow you to do this. If so, I didn't know. Okay, maybe. Should work now. I think it's thinking. Yeah, it's working. Okay, you can see downloading here. Embedder is not a valid choice. Let's go with DeepSort. Is it mobile? MobileNet? Yeah, it's mobile with E here. Okay, mobile net. Okay. Again. Okay, wait a minute. I'll share it with you. Let's see if this works. Okay, cool. It works. Oh, works, but okay. Meme, you that one last line. Yeah, I added here. Remember, it was int x1, and this int repeated for this one, and this one. Get rid of these ints and add them here. In the put text line, should be int x1, int y1 minus 10. Okay. This one's over here. So you pass this soccer.mp4. You can call it like this if it's inside of your folder. If you have it in another folder, you should call it from that folder. Okay. So for example, if it's like videos / soccer.mp4, it means inside of this folder, you have another folder called videos, and you can find it there. In my case, it's here. So, no worries about this. Okay, now, we got an error. It says left top, right bottom. Okay, my bad. Left top, right bottom. Left top, right bottom. LTRB. Okay, left top, right bottom. Okay, cool. Now, don't run from errors. Okay, please, please, please. Always try to read them. It makes you a really good coder. Okay, cool. Now we can see this. Okay, I'm running it with Conda. That's why it goes smooth. Okay, Meme, you're going to see that with env, it doesn't go that good. Okay, it still works, but it takes more time. Okay, cool. So you can see here, it's Chile versus Mexico. I'm from Mexico, so why not? You can see that we're recognizing lots of things. These are people. These are people. You can see we have IDs. See this? Now, ID 312 stays there. You can see that? This guy right here, 312, stays there. What did this mean? It means that this ID, or in this case, 373, it's this one. This dude over here, number 4, DeepSort is saying, hey, I remember that dude. We should not count it as a different person. It's the same one. Yeah? For example, the ball. Okay? Now you can see 654, and then it changed to 695. Now it changes to 709. It kind of bugs a little bit there. It stays the same. We have another ID here. All of those are parameters that we can change. Okay? Now, whoever's from Chile, I'm sorry, 1-0, my bad. Yeah, let's hope that we win this World Cup. We never do. Mexico never does. Why? I don't know. It's just I don't know. I feel like, especially this team, okay? I'm going to say it. We're not going to win because the team is made up by people that are not familiar with each other and they're pretty young. Okay, so I don't think we'll win. I hope that we win at least 2 of the games. That should be good. Okay, see that? For example, this person here is person 1000. Okay, it means see this? It lost it there. It will count it as a new person later on. Okay, see this? It's 1300. Okay, this is cool. Yeah, this is cool. Now, this is a little bit of not cheating, but it's not what we trained. Okay, this right here means I want you to give me the weights of YOLO by default. But we just trained YOLO, right? Go to your Google Colab. Okay. Yep, no worries. It takes a little bit of time, so no worries. Go to your drive because everything is saved in the drive. In our case, remember, it was YOLO 11S Football 6. Okay. We have a bunch of things here. Okay. First of all, the weights. Okay, we're going to use best.pt. It means from the 50 epochs, this is the best one the one that had the most score. Okay, you can find the last one too. I usually use the best. Okay, cool. Now, before downloading anything, embrace yourselves. Okay, we have a lot of things here. Okay, for example, here we have images, and you can see that it actually tracks everything as we want to. Here's a little bit of a silhouette of the goalkeeper. Here's the ball, referee and referee. Maybe these two are not referees. Those are the trainers, okay? And all of these are players, okay? Cool. What about a validation badge? You can see here referees. Here it's like the player icon here. It's not letting us see it. We have a lot of players. Sadly enough, I don't see the ball. Okay, for example, here we have player, 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 player. I'm not seeing the ball. At least I don't know if it's here hidden. Okay, it maybe is. Okay, let's take a look at another image. Here's the ball. See, it can see the ball. Okay, module what? Really? For pip? DeepSort real time. That's interesting. DeepSort real time. Is it correctly written? You sure? With pip? So install Ultralytics first and then DeepSort real time. Realtime. Yeah, it's fine. Shouldn't have gotten that error. I have now installed it. Ah, cool. So it worked. Okay, nice. Cool. Okay, so this is part of what it says. Okay, let's go up and take a look at math. Okay, don't run from math. Understand math. Okay. We got the labels here. You can see this is horrible. Okay, this is one of the worst things that you can do, and this is why I always tell you check your datasets. Okay. You can see that ball, goalkeeper, and referee we have like very few instances. We have nearly 6,000 players. Okay, we are overfeeding with players, and that's not good. Okay, well, I just got name self is not defined in lines 5. Go to here, init. Should have self by default. Okay. You know Hindi? I do not. I'm from Mexico. My bad. Apologies. I do know Spanish though, and I can speak Arabic and French, English, and teeny tiny bit of Italian. But no, not Hindi. I'm sorry. Okay, cool. So this here means you can see that it's scattered mostly everywhere. This is good. It means it finds lots of things in various parts of the images. Okay, that's good. You have self there. You said line 5. and 1, 2, 3, 4, 5, you name self is not defined lines 5. Ha. Everything, okay, so just double check that everything of self is inside of your object. Okay. Yeah, but not like it shouldn't be like this. Not like this. Like this. So inside of your class, everything that has to do with the class should have in self. Outside of the class, nothing with self. Okay. For example, here, nothing with self. Okay. Double check if everything's inside the class. Cool. So let's get back to this. Cool. Now, confusion matrix. Okay. Cool. Now, let's take a look at the normalized one. Okay, so it's easier to understand. X value, your true positives, and these are the, my bad, these are the predicted ones. Okay, so you can see that the ball as a truth is being, in a way, unpredicted by the background. See that we are having trouble between ball and background, and that's understandable, right? The ball is pretty small, so it gets a lot of errors between background and ball. You can see the actual truth of the ball is 0.4, so 24% of the time that it got the ball correct, and 76% it was the background. Okay, we need more ball in the data set. We don't have it. It's okay for now, but that's what it means. Okay. Indentation issue. Yeah, always happens. Cool. Now, for goalkeeper, you can see here it's nearly good. 10% of the time it's background, and 13% of the time is a player. Understandable. Usually it's a truth. Okay. You have to see the diagonal with truths. Okay. In this case, referee is good. Player is really good, 92%. Understandable. We have a lot of players in the dataset. Okay, cool. This is what a confusion matrix looks like. Okay, now. Okay, let's go one by one. Okay, let's see if I remember what these mean exactly. Okay, let me take my cheat sheet out. I always forget, and when explaining, I have to get it right. Okay. So F1 means precision over recall. Okay, what is precision? Let's do precision over recall. Actually, not over. It should be versus recall. There's an image here that shows us. Oh, there we go. This is the one. Is it this one? No. Where is it? There's a beautiful image. This is just a Venn diagram. Nope. Here it is. Nope. Oh, this is the one. Okay, cool. Is it this one? No. Where's the? Wait a minute. Well, let me just find it. Yeah. Okay. Cool. So you can see it here. You can see if we have false negatives, it means we got wrong negatives, but good positives. It means the precision is all of the truths that we got over everything. That's what the precision looks like. It means every good for everything. Okay? Recall is I want to get every good or every corrects over corrects and incorrects. Okay, so the precision means how many selected items are relevant, and recall means how many relevant items are selected. Okay, a little bit of a game of words there, but yeah, that's what it means. Okay, meme says exception either embeddings or frame must be given. Okay. Check if you have embedder here. and embedded true. Okay, and in the tracks, frame equals frame. Okay, again, in your embeddings in the self-load tracker, embedder equals mobilenet, and then embedded GPU equals true, and then go back to, in my case, it's line 71, tracks, frame equals frame. Works? Should be that, okay? Try it again. Cool, so that's precision and recall, okay? Cool. Now, these numbers, if you divide precision over recall, you get something called the F1 score, okay? You can see that you had that already. Exception, either embeddings or frame must be given expected. That's weird. I'm not sure what this error means. Does it say which line it's talking about? And if it says, tell me what's in that line. 198 update tracks. Okay, we don't have 198. Do you have 198 update tracks? Yeah, should be here. Do you have this and this? Is the frame okay? Like this? And the detections are okay? Like this? Check this. Okay, cool. Confidence means the confidence of the model when it predicts something, okay? Let's say that I found my iPod today, like my iPod 4, it's mini. Like this is my iPod. This is my phone. This is a Samsung S25 Pro, is it? No, Max. I don't know. The one that has the pen. Check this out. Can you see this? It's a miniature. It's nothing. See that? Okay, cool. Now, let's say that I know that this is an iPod, okay? Let's say that I can know certainly 100% this is my iPod. My confidence is at 100%. Okay, so I have no errors in this case. Let's say that I am confident of 25% because I'm looking at it this way, like this. Okay, so I get more errors with that. Okay, so usually having confidence lower doesn't mean that it's not confident enough, but it means in confident 20%, I'm actually getting the best results. Because when I'm 20% sure of it, I kind of get the idea of it. See that? Now you can see that the ball is the one that's lower. Okay, so this means add more images of balls. Okay, in the field. Cool. Now, oh, just pasted the error and automated flagged it. Having the links. These are not links. It's just the error and automod flagged it for having links. These are not links, just files of exception. Oh no, it's fine. But I don't know how to help you. Like I would usually say share your screen, but it's not the case. What you can do is debug later. Go to my GitHub and use the object detection.py. It's here. Okay, and you copy the whole thing. It should work. Okay, it's the one that I just used. Okay, cool, awesome. Let's get back to our notes here. Okay, that's F1 confidence curve. Now we have precision confidence. So how precise I am when I'm confident. And it's usual when I'm 100% confident, it means I'm very precise. But careful with, in this case, goalkeeper. Okay, because precision it's still going up, but it's fluctuating a lot with the ball too, because the ball is really small. Okay, cool. Now, this is helpful. Okay, I'm running out of time, so let's use the weights. Download the weights. Okay, click here, download. In my case, I have downloaded like 5 of them, so I won't re-download it now. But I'll go to my Here it is. It's best one. There we go. So, Meme, were you able to use my code? Use the code that I have on my GitHub and then debug. Go to your YOLO and here do best space, should be best.pt for you. In my case, it's best1.pt. Okay. Now you'll see a big difference. Okay. 3, 2, 1. This is with the weights that we trained. Okay. So where's the video? Here it is. Let's check it out. See, now it doesn't see the people that we used to see before. See, we had a lot of boxes here. You can see we have people here, and it's funny. You can see that this ear is someone. Oh, but look at that. Now we're looking at the people that we trained the model with. But this is just horrible, right? Like we're getting 5 or 6 boxes per person. This is horrible. Okay, let's tweak some things. Okay, I'll go here, Control C this. Cool. And now remember, I told you and I promised I was going to explain all of this. Max age means the amount of pixels DeepSort will remember. Let me put some light in my face. Wait a minute. How can I do this? Maybe here. No, I'll do drive. Reminders, GitHub. Oh, this. Okay, cool. So max age is whenever, in this case, a player disappears, it has 5 frames of, let's say, of memory that DeepSort will remember that specific person. If it doesn't appear in 5 frames, DeepSort will automatically forget about it. If it sees it again, it's a new ID. Okay, cool. Now, n init means the number of times something has to appear, or in this case, some person has to appear before we classify it. Okay, so for example, we have to have someone in 2 frames at least for us or for DeepSort to classify it. Okay. Max intersection over union. It means I'll actually show it. It's easier if I show it. Intersection over union. Okay. Here it is. Okay. So this is poor. Okay. One is the predicted one, which is the red. One is the green, which is the true. This is poor because you can see the areas. We have small areas in between. That's why it's intersection over union. This is good. Most of the areas are intersected. And in this case, it's excellent, but careful with this over here. Okay, so you can see IOU 9264, this. I'll open it in a tab so you can see it better. IOU 7330, this. 73%. I would say this is like, I don't know, 80%. And IOU 4034, it's this. Okay, so this is IOU. Okay, so what this means is, if we go to max IOU distance, it means how strict we are when we are trying to figure out if that's that. Make sense? So if YOLO says, hey, here's my iPod, okay, here it is. And DeepSort says, okay, the iPod moved just a teeny tiny bit here, and now the intersection is like right here. Make sense? I think I'll open Paint. I have 7 minutes to show this. Okay, so I can do, I don't know, let's say that YOLO says, hey, here's a player. And now the player moved, and now the player is, I don't know, right here, okay? So now this is the new player here. Now, you can see that this part over here is intersection over union. So DeepSort says, hey, this is not a lot of intersection over union. This person over here is not this person. Or we can tweak it and say, hey, this is enough. Okay, so this is enough. We have enough of intersection over union. This person is the same person. Make sense? I hope it makes sense. So you could see when I ran the code that we had a lot of boxes. Okay, let's add something. Oh, let's just finish with this first. Max cosine distance means, I have my cheat sheet here. I forgot what max cosine distance is. I think it's about the classes. Just let me just double check and confirm. Where is my cheat sheet? Come on, metrics. Nope. Did I just forget? Wait a minute. What was that? Oh, I'm just dumb. I didn't get it. Okay, cool, awesome. Let me just Google it real quick. I just forgot what it was. Max cosine distance. Okay, so DeepSort. Okay, let me just double check real quick. Real quick, what was it? AI? Can AI help me? Oh, let's just do Gemini. What's max what was it? What's max cosine distance for DeepSort? I think it was about the flickering. If okay, let's just see what Gemini says. It's easier. Is a key hyperparameter algorithm that acts as a matching threshold. Oh yeah, that's true. So one is about location and the other one is about similarity. Okay, so for example, with my iPod, if I have my iPod like this and in the next frame I have it like this, DeepSort will say, hey, this is not an iPod. Okay, but if the first frame is like this and in the next frame I have it like this, churning a little bit, that it's still somewhat similar. And if I keep churning, the similarity will change. So I can turn in 10 frames my iPod and DeepSort will say, this is the iPod. Or I can turn it in 1 frame and DeepSort will say, that's not an iPod. Okay, so let's tweak those two. And I had my cheat sheet here. Let me double check how much we had. I used, for the one that works, 0.15. Okay, so we're going to allow overlap, but very strictly, because we know that players are moving. We don't want DeepSort to confuse one player with another one. Okay, 0.3 in appearance. So we are strict. The lower, the stricter. Okay, we are strict because we know that teammates are dressed the same. We're not focusing on the numbers, faces, and we cannot trace other, let's say other ways to see who they are. So let's be strict about it. Okay, so 15 and 0.3. So 15, 0.3 is okay. Cool. Now let's add some confidence to YOLO. The one that worked the best, okay, is 0.7. So let's do conf equals 0.7. Okay, cool. Now let's see how this looks. Okay. Come on, there we go. Take a look at the video. People there. Okay, no worries. Remember that there was one of the ears was a person. Check this out. Now we are losing people. See? So instead of overseeing people, now we are losing people. This means the confidence of YOLO is too high. For that confidence, we're asking too much of YOLO as we trained it. Let's ask less. Okay. What happens if we do 50? Okay, confidence at 50%. Okay. Let's run it again. Come on. Maybe we'll see a person in this ear. Yeah, we saw it. Ooh, check that out. Now, we can see better. It doesn't overlap as before. This is the best that we can do. You'll ask, hey, but if we use the other weights, the one that we didn't train, it worked better. Well, true. Then the problem is not DeepSort. The problem is the way we trained YOLO. The dataset is not that good. And we trained it for 50 epochs, which is not that good. And there was no data augmentation. So it's not that good. It still does the job. But see, it lost here 1. It's not doing a very good job. The goalkeeper is not being ID'd here because maybe we should add less confidence. Okay, so if we use the usual weights, the weights that we didn't train, should be YOLO 11S, then you can see we can see people, okay? There is no flickering weird, how do you say this, weird rectangles, okay? Okay, people, okay? Kid, people, Mr. Suarez there we go. See, now this is very stable. Very, very stable. We can see that there's a confusion here, but it's not that bad. So it's not DeepSort, it's on the YOLO side. Okay, that's how you learn to tweak either YOLO or DeepSort. Okay, so far so good. I hope that this was an interesting project for you. I hope that you had fun. Stream is over. So any questions that you have, anything that you'd like to ask, in the meantime, I need you to, if you could please give me feedback. Okay, I want to know if you like this this stream. Thank you so much for the claps. Let's go to this part over here. If you go to the survey, continue, instead of this one, should be what? DeepSort, object tracking with YOLO and DeepSort. Okay. And if you didn't like it, press a 1. If you like it, but not that much, 7. And if not, a 10. Nothing is personal. I want to get better, so I need your feedback. Okay. Cool. I wish there was more time too. I can do a second part of this. Okay. Meme, stay tuned for Global Hack Week streams, and I usually stream each Global Hack Week, so I'll think about a part 2 of this. Okay. But yeah, please give me feedback, and just in case, here's the link for you to register. Okay. Do you have any questions for me? Let me zoom in. Ooh, that's good. All good. I'll give you 30 seconds for questions. If not, if you want to connect as Bully1601 in on Discord, and if you want to find me on LinkedIn, my name is Treble Brady. Okay, so you can follow me on LinkedIn too. That was great. Thank you so much, Mossy. I hope it was good. You have my GitHub there if you want the codes. The only thing that I didn't put is the video. But yeah, I shared the video on Drive, okay? Which, by the way, huge thanks to whoever posted it on YouTube. But yeah, that's not my video, by the way. It's someone else. I have got 40 points. How can I use them to have swags? I'm not sure. Ask it on the Discord, okay? They'll help, okay? Usually Way helps with this, so ask on the Discord, okay? I don't have an exact answer for that. Let me remove this. That's better. Cool. Thank you all for joining. I hope I'll see you next Global Hack Week. If not, then yep, thank you for joining Global Hack Week 2. If you're interested in the fellowship, let me know, and I'll give you some interesting insight of how it works and what it is. And yeah, I'll be seeing you around. I'll stream next Global Hack Week. I'm not sure about what, should be fun. Thank you for joining. And if any questions, let me know on Discord. Okay. Take care. Enjoy your night. Bye-bye. Ooh, comment? Cool. As long as it run, everything's good. Now, don't use pip for this one. Use conda. I know you don't like conda. Conda is better. And for this case. For everything for vision, conda. Okay? Take care. Bye-bye.